Hey stats students, welcome to chapter 2. I'm super excited to get started on this because we get to start doing some data. And if I can ever get rid of this, here we go. So the chapter is called Frequency Distributions and Graphs. So it's all taking our data, everything that we've collected using representative samples and good questions and good sampling methods, all those kinds of things. And now it's all about what do we do with this data. So the first thing, we need to organize our data in a meaningful way. So we use it to describe situations. That's descriptive statistics, right? It's data only. But we also organize our data to draw conclusions or to make inferences about events. That's inferential statistics. So using our data in some way graphically helps us to use descriptive and inferential statistics. So the first thing that we're going to focus on is a frequency distribution table. You're going to create these. You're going to become experts at frequency distribution tables. First of all, this is the most convenient method for organizing our data. This is kind of our go-to thing. When we got a bunch of data, let's make a table. It's going to organize it for us. Frequency distribution is a table form that uses classes and frequencies. So really, it looks like this. This is kind of like the parent graph, the most basic. We can add more columns than just class and frequency, but that's our most basic starting point for a frequency distribution table. So since we're using classes and frequencies, we should probably talk about what they are. So a class is a qualitative or a quantitative category. So down that class column, if we're talking about the colors of shirts of people, we might have red, blue, purple, and green. Those would be our classes. If it's quantitative data, it might be 1, 2, 3, 4, or 0 to 2, and 3 to something. So those classes can account for both quantities and qualities. This describes or groups our data, and I shouldn't have put counts here. I should have just put describes or groups our data. So again, it's a way to organize it. So then once we've got our classes, we go to our frequency. Frequency is the number of data values contained in that class. So when we go through all of our data, how many red shirts do we have? That's what we would put in the frequency column. Or how many pieces of data between 0 and 2 do we have? We would put that in that frequency column. All right, so let's create or talk about and create qualitative data. And it says using categorical frequency distributions. That means we just have categories instead of numbers. So qualitative data, qualities. So this is used for data that can be placed in categories. I don't know, maybe you don't want to write down such as nominal and ordinal data. We know, right, that nominal and ordinal data are typically qualitative. Ordinal, we can put things in order. Nominal, or there's some kind of ranking. Nominal is just groupings of things. So first step, we're going to make a table. We're going to have 3 columns this time. We're going to have class, frequency, and percentage. Then we're going to count the frequency of each category. Some people like to use tally marks. Others don't. They just count or cross things out. I don't get picky about that as long as your frequencies are correct. Third thing, calculate your totals. Also make sure that you double check and count all your frequencies and make sure that they equal the total number of data. The total number of data is our sample size, and we use the letter N to represent that. And last but not least, do a quick calculation. When you fill in your percentage is the frequency over N. Perhaps you like to write it this way, frequency over N. And then, of course, if we're going to turn it into a percentage, we're going to do times 100. I should have jotted down that n equals the sample size. I just said it, but just to make sure. And just so we know, we're going to do, when we do qualitative data, we're going to round to one number after the decimal. So it would be like 28.2%. If there is no rounding, obviously we wouldn't do that. All right, so let's make a quick table. Unfortunately, I already put the classes in this table. I don't know what I was thinking, but this is a blood type practice. 25 Army inductees were given a blood test to determine their blood type. Here is our data set over here. My first couple of questions I want to ask is, what is the sample size? Well, you could count 5 by 5, or you could also notice up here, we're getting information from 25 Army inductees. So there should be 25 pieces of data. Second of all, do you see that this is qualitative data? There's no quantities involved. It's either A, B, O, or AB. So it's qualitative data. So then we're going to go through and we are going to find our frequencies. So I'm going to figure out how many type A blood types are there, how many Bs. If you like to do tally marks, feel free to do tally marks. Remember, it's 1, 2, 3, 4, and then cross it for a 5, and that way you can count up your little bundles of 5. I'm going to quickly jot these in, double check, make sure that you've got the same numbers, hit pause if you need to. Hopefully you got the same values as I did. I got frequencies going down. Blood type A was 5, B is 7, O is 9, and AB is 4. I did add up these frequencies to verify that my sample size is 25, because if I miss a piece of data, my whole frequency table, everything's off. What's the point of doing a study if you don't include everything? And then I'm going to figure out my percentage. So remember, percent was equal to frequency over N times 100. This one's kind of an easy one because I picked nice numbers for you. But I would do something like 5 over 20, which is equal to 25%. Oh, I'm sorry, 20%. 7 out of 20 is 28%. Remember, I don't have a need to go to one number after the decimal here. So what should all of my percentages add up to at the end if I'm adding up all of my frequencies to the total sample size? Those should all equal to 100%. If we were rounding, we might not come up with 100%, but we've got 100%. All right, what do you think about these qualitative frequency distribution table? Not pretty easy, right? Percentage is really the only extra thing that we add from our base model of class and frequency. So let's talk about grouped frequency distributions. Group just means that we have groups in our classes. And when I'm talking about groups, I'm talking about like from 0 to 5 and 6 to 10 or whatever it might be. So grouped frequency distribution. We use this with a large amount of quantitative data. I'm not sure if I told you before, but we, as statisticians, we always like our sample size to be at least 30. That's a lot of data. So we typically end up grouping it on our frequency distribution table. Our table will always start with the lowest data value. We don't start with 0 unless 0 is our lowest data value. We always know that our highest limit might be bigger than our data. I'll show you what that looks like when we do one. We have to do a calculation to start off with. We have to find our class width. I'm going to say this probably 4 times. When you find your class width, you always round up. Even if it comes out to like 6.002, you always round up to the 7. So always round up. And last but not least, we're going to complete our lower class limits using the class width. I'm going to just jot down, we're going to go down the left column. This is probably a lot of information and you're not quite sure where it fits yet, but keep up with me and it will all kind of fall into place. All right, so again, we've got quantitative data, and we need a way to organize it. So we're going to do that, but we're going to calculate everything so it all falls in there nicely. So let's talk a little bit more about these, and then we'll get to the important stuff. Not that this isn't important. So when we organize our quantitative data, the first thing we've got to do is we have to make sure that our tables are right. These bullets right here, I'm going to ask you in an assignment to look at some already pre-created tables and double check these things. So I'm going to ask you to look to make sure are all of our classes in equal width. That's important. We are going to find the class width, I mentioned that, and we have to make sure they're all equal, whether we create them or not. We need to check to make sure that all of our values within the range, sorry about that. We have to make sure that all of our values are within, oh my goodness, I'm struggling all of a sudden. All of our values are within our range must be included. Again, what's the point of collecting all this data if we don't include all of it on our frequency distribution table? We have to have values in at least the first class and the last class. If we have zeros for our frequency, what's the point of even putting them on there? The zeros can be squished in between, but the first and the last, the top and the bottom class, have to have values in them in the frequencies. The classes may not overlap. Another way to say this, if you're familiar with the term, the classes have to be mutually exclusive. I can't make it so that I've got a table, class and frequency. I can't make a table that this goes from 0 to 5 and this goes from 5 to 9. Because where do I put the 5 then, right? Where do I make a tally mark? The classes may not overlap. And last but not least, the classes have to be continuous. So even if I don't have any pieces of data that are 6 or 7, I can't just jump up here and go to 8 to 13. What happened to 6 and 7? 7, 8, 9, right? We can't do that. So we have to have continuous classes even if you have 0 frequency for them. Our first and last classes have to be included or have values in them in the frequency, and the classes have to be equal width. So we'll do more practicing with those. But here's what we do. In order to create a frequency distribution table with all of these important qualities that you're going to learn how to look for and be able to put our classes and our frequencies in there, the first thing you need to do is find your upper and lower class limits. In other words, we need to, you know what, don't write that part. Determine the range. This is the important part. Remember, range is highest minus the smallest. So you have to look at your data and see what you got. The range is important because you're going to use it in step 2 to determine the class width. I may have mentioned before, when you calculate your class width, you will always round up. Even if it comes out to, like you divide and you figure out for your width that it's going to be 6, comes out to 6 exactly, we still round up to 7. So we always round up. Step 3, define your class limits. And I mentioned this just a page or 2 ago. Fill in the left column first. And then you're going to go ahead and actually find your frequency for each class. So again, a lot of information. Let's talk about a little bit more information, and then we can actually make a table. All right. So, class width. I've mentioned it a couple times. Class width, you do your range divided by the number of classes. And remember, in case you didn't hear me say it before, always round up. Hopefully, if you need to add something extra here, the range is the highest minus the smallest. I don't know if you're aware of that, but jot it down if you need to remember it. We're going to always use the class width in every table. Class boundaries, midpoint, all these other things are extras that we can add to our frequency table. In addition to class and frequency and maybe tally marks, we could add any of those things in there. So class boundaries, I had a hard time figuring out a good way to say this, and I'm not sure if this is even good. It's the midpoint of the previous and the current class. We will work on that. And you could have decimals here. No, actually, for class boundaries, you will have decimals. All right, so don't think you did something wrong. Midpoint is the average of the upper and the lower class limits. So if a class goes from 0 to 10, we would take 0 plus 10 divided by 2 to find the average, and the midpoint would be 5. I don't have anything to put in that second box over there. Cumulative frequency. If you know the word cumulative or the root word, think about accumulate, right? Cumulative means add. Whoa, sorry. So in cumulative frequency, we are adding the frequencies. So the sum of the frequencies as you go down the table. There we go. And your final value should be n, and what does n stand for again? Sample size, how many pieces of data you had. Relative frequency, we just found that on our blood type thing. Relative frequency is the frequency divided by n. Typically in qualitative situations, we call it the percentage instead of the relative frequency, but it's frequency divided by n. And I made a little note here. When we're dealing with quantitative data, quantities, we typically just leave it as a proportion. 3 decimal places. 3 decimal places. If we're dealing with qualitative data, like when we're working with our things like blood types, our qualitative data, we typically go to a percentage. So just a little thing for you there. And last but not least, cumulative relative frequency. So we could accumulate or add our relative frequencies. So it's our sum of our relative frequencies as we move down the table. We will practice these things as we go. And our final value here should either be 100% or 1.0 if you're just using proportions. All right, so let's make a table. We've got some data. It is the ages of the wealthiest people from Forbes magazine in 2018. Sorry, it's a little outdated. Notice down here it says make a frequency table with 6 classes. I will always tell you the number of classes. So the first thing we need to do is find the class width. Remember, the class width is the range divided by the number of classes. Well, I just told you that I want 6 classes. The range is the highest minus the smallest value. I'm pretty sure I'm seeing up here a couple 90s as my highest value, and I see a 34 as my smallest value. So 90 minus 34 is something like 56 divided by 6. I believe that comes out to a 9.3 repeating. Golden rule of finding class width, we always round up. So that's going to become a class width of 10. No matter what, we round up for class width. First thing we do is class width. The second step that it said under the, actually the first step was to determine the range. Second step was to find the class width. Now we're going to define our class limits, and we're going to fill in the left column first. So we said earlier, we always start with the lowest data value. Our lowest data value, according to finding the range, was 34. So our first class is going to go from 34 to something. Your instinct might be, well, if our class width is 10, I'm going to make this 34 to 44. No. Erase it. Don't write it down. That is not right. When we do this, and I said fill in the left column first, we use the class width, and we add down the side. Width equals add 10. So my next class will start at 44. The class after that will start at 54, 64. So as we keep on adding our plus 10, we're filling in our left-hand column. This is so crucial. So then what we're going to do is we're going to figure out, all right, well, if this second class starts at 44, the last one has to end at 43, right? Because I have to make it continuous. So if this class ends at 54, starts at 54, the one before has to end at 53. You'll notice your class width brings you right down. It's going to be up 10 down the right-hand column as well. That gets tricky for people. Sometimes if you can't figure out your final class limit, figure out, well, my next class would start at 94, so the previous one ends at 93. So from there, we're going to go through, that's the tricky part. Now we're just going to figure out our frequencies. I'm actually going to, I'm going to quickly jot down my tallies and my frequencies. You feel free to hit pause, and let's make sure that we got the same frequencies, because that's the important part. Do your frequencies look something like this? So going down, I had a 2, 8, 12, 9, 14, 5. When I added all those up, it added up to 50. I know that I should have 50 pieces of data because it is the top 50 wealthiest people in the United States. I put my tally marks and my frequencies right next to each other because I was thinking, well, maybe besides just having our basic classes and frequency columns, we could talk about sometimes maybe we'll do midpoint here. Or maybe we'll do relative frequency. Or maybe I'll have you do cumulative relative frequency. So we'll work on those in class, but let's make sure class limits are the #1 priority, and then getting your tallies correct, whether you use tally marks or not. All right, one last thing. There's another example. Notice all the stuff that I put on this table. We can work on that in class. And I also notice it says 8 classes, right? Because I'm always going to tell you how many classes that I want, because that's where you do your range divided by n. But let's talk about a cumulative frequency table real quick here. This shows your class limits with only an inequality and upper boundary. So we're accumulating things, so we're saying everything that is greater than, or everything that is less than this value goes here. So we keep accumulating. The class limits become open-ended. So we're going to have something like, I think I've got a practice here. We're going to have something like everything less than 0, less than 8, less than 16, less than 24. So we're going to accumulate our frequency as we go along. Our first class limit, we're going to have nothing. And then we're going to add up how many pieces of data do we have less than 8? How many pieces of data do we have less than 16? So it's always going to get bigger as we go. Our final value, our last limit, should always equal the total number of data values because we've accumulated all those data values along the way. We'll talk about this as we go, but I did just want to touch on it and so that you saw what that open-ended thing meant. Thanks for hanging in there. This was a long section of notes, lots of information, and lots of fun to be had as we start working on these. Have a great day. I'll talk to you later.